Okay, good. Okay, so the word composite. Composite solids are objects composed of multiple 3D objects. Okay, so that first blank is multiple. Okay, so truthfully, with these, it's really a matter of knowing how to find volume of a couple different things. Okay, so if you look at, for example, this first one. Okay, that's a composite solid, but there's not a formula, one single formula that works for that, right? What do you think I could do to make this easier?
You separate.
Jackson?
You know what? Never mind.
Well, I mean, you were on the right track, Ellie. What did you say?
You separate them and then you
So-
do the two different shapes and then you add them up.
Okay, if I can break this into two different three-dimensional figures, then find the volume. Okay, what is this basically made up of? A what?
Sphere.
A cylinder and a cone. Do you know how to find volume of a cone? Do you know how to find volume of a cylinder? Okay, so what we're going to do, we're just going to write each formula because we have a cylinder and we have a cone. We're going to write the formula for each one. What's the formula for volume of a cylinder? Anybody remember? Pi, say it. Pi r squared times height. And what about a cone?
Squared times height divided by 3.
3, good. So let's look at this first one. Am I given a diameter or a radius here?
Diameter.
This is a diameter, so I need to turn this to a radius. If the diameter is 8, what is the radius?
4.
Okay, so I have a radius of 4 feet. So I can plug that in here. Volume equals 3.14 times 4 squared. And what's the height of, I'm only concerned with the height of what? The cylinder, which in this case is what?
4.
4. Okay, so now we have volume equals 3.14 times 16 times 4. And what do we have when we do this? 3.14 times 16 times 4.
200, 9.96.
3.14. Yeah, so we'll just say about 201, because on today's worksheet, on today's time, I just want you to round to the nearest whole number, okay? So we're going to say about 201 feet cubed, okay? Now, we're going to do the cone, and once I have both of these, what am I going to do with each volume? Because I want to know the volume of this whole thing. What am I going to do with those, do you think? Jackson? Yeah, combine them, put them together. Okay, so I've already found the volume of this whole thing. Now I need to find the volume of the cone, right? Well, I discovered a potential mistake in my first period class because several of them tried to take a shortcut. What do you think the shortcut they took was?
Just dividing 201 by 3.
They just divided it by 3. Why does that not work?
Because the height becomes 5.
Because the height is not the same for each one, is it? Okay? Because the height on the cone is 5, but the height on the cylinder is 4. If the heights were the same, I could do that, couldn't I? But they're not. So let's plug it in. 3.14 times 16 times no longer 4. What is it now?
16.
Times 5. Okay, and we're going to divide all that by 3. So 3.14 times 16 times 5 is 251 point. We'll just say 251. We're going to divide that by 3, and we have what?
84.
About 84. So volume is about 84 cubic feet. Now what are we going to do with this and this?
Add them.
Put them together. So if we put those together, the volume of this entire object would be about
285.
285 cubic feet. Okay? You see how we found that? Is that difficult? All we do is break it into three-dimensional figures that we know how to find. Question?
Why do you change the 4 to 5?
Because the height of the cylinder, okay, look up here. The height of the cylinder was 4. Okay, but the cone, the cone is down here, and the height of this cone from here to here was 5. Okay? All right. Okay, let's look at this one. Okay? What do I notice about it?
There's a rectangle.
It's a half cylinder.
It's a half cylinder, okay? So we've got a half cylinder.
So we just divide by 2.
Uh-huh. So a half cylinder, what's this other thing? We didn't do this year, but we did it last year. What is that other thing? This,
Rectangular prism.
it's a rectangular prism. So on a rectangular prism, what's the volume? Length times height times width, or base times height times width. Okay, we'll just say length times width times height. And if I'm going to have a half cylinder, what do I have to do? Pi r squared times height. And we're going to take all of that and do what with it? By 2. Why? Because it's only a half cylinder. Okay. So let's do the cylinder first. Okay. My first period class had trouble trying to find the radius here. Why? Because it's not right on the shape. But if this is a rectangular prism, do I have a radius? I don't have a radius, but I have a diameter, which I can turn into a. That means if this is 25, guys, what is this?
5.
Okay, so from here to here would be half of 25. So what would the radius be here?
12.5.
12.5 centimeters. Okay, now, the other thing they said, well, we don't have a height. But do we have a height technically? If this is 50, what is this?
50.
Okay, so do we have everything we need?
Yes.
Yes, we do. Let's plug in numbers. Okay, so volume equals 3.14 times 12.5 squared times 50 divided by 2. All right, so 3.14 times 12.5 squared is 156.25 times 3.14 times 50. And that's about 24,531, right?
Sure.
And what are we going to do with that? What are we going to do with this number right here? Divided by 2, because it's a half cylinder. So our half cylinder has a volume of about 12,266. Okay. Now on this one, all I got to do is plug them in, right? So does it matter which one's my length, my width, or my height? Question. Did I do something wrong?
Did you square the 12.5?
Yeah.
What'd you get with that?
156.25 times 3.14 times 50. Yeah, that's right. Okay, does it matter which one I make my length, my width, or my height? In other words, if I multiply 1 times 2 times 3, is it the same as multiplying 3 times 2 times 1? It doesn't matter what order you multiply them, right? So you can just plug them in. So I can do 50 times 25 times 30. And what do I get when I multiply all those? 37,500, is that right? Okay. And this is feet or centimeters cubed, centimeters cubed. What do I do with these two?
Adam.
I put them together, right? Okay, so let's add those together. And what did we get?
49,000.
So we're going to say, now, I have to use the about. I don't have to use the about on this one because there's no circles involved, but anytime there's pi, I have to use the about. So this is about 49,766 centimeters cubed. Okay? All right. Do we see how we found that one? Yes? Okay.
Is that decimal place in that?
Say again? What decimal?
Oh,
Yeah, that's common.
that was a decimal. I was like, how-
Okay, now, I think you understand the process of this. So on the other two examples, I just want to go over how we would find them, rather than spend all the time doing it. Okay? So if you look at this next one, okay? This is a cube. What's the volume for a cube? Length times width times height, right? And I also have a cylinder, but am I going to add the cylinder to this? Okay, this is like a hole that goes down the middle of this cube. So instead of adding the volume of the cylinder, what am I going to do with that? I'm going to subtract the volume of the cylinder. Okay, do you want me to do this one real quick, or do you understand how that's done? I can do it real quick. That's fine. Okay, volume of a cylinder is pi r squared times height. Okay, so let's plug in some numbers here. If it's a cube, all the sides are what? The same. So that's 12 times 12 times 12. What is 12 times 12 times 12? 1728?
Yeah.
Yeah. Millimeters cubed. And then this is going to be pi, so 3.14. Is this a radius or a diameter?
Diameter.
It's a diameter. So what's my radius going to be?
1.
1 squared. What's 1 squared?
1.
1. Now what's the height?
12.
Times 12. So if we multiply 3.14 times 12, what do we get?
37.68.
So can we round that to what? Say about 38. So about 38 millimeters cubed. Now, just like I said, we're not going to add these together. What are we going to do with these? Subtract them. So 1728 minus 38. Okay, what would that give us?
1690.
So this would be the volume of the figure without that cylindrical hole through the middle would be about 1,690 millimeters cubed. Okay, does that make sense? All right, so just tell me on this one, okay, what would I do with those two? First of all, what do I have here? What do I have to find in order to find the volume of this? Tell me what this is made up of. A cylinder and a what? And a hemisphere, right? So I could find the cylinder easy. How do I find the volume of a hemisphere? Volume of a sphere divided by
3 divided by 2.
2. So divided by 3 first, then divided by 2. But can I show you a shortcut? Instead of multiplying by 4 at the beginning, if you're trying to find a hemisphere, multiply by 2 at the beginning. You'll get the same answer. Okay? Make sense? All right.
Can you say that again?
Instead of multiplying, your formula for volume of a sphere is 4 pi r cubed divided by 3. You can do 2 pi r cubed divided by 3, and you get the half sphere. Okay? All right, are we good on this?